The basic difference between portable instruments and online systems is just one. The online units measure continuously all the time, and it brings one main trouble. The amount of data is huge. How to handle with them in reasonable time? In the past, when the size of hard drives was in megabytes, the user had to plan very carefully what to measure and how often. It always had to be a compromised solution. Hard drive size seems endless nowadays, and processor speed seems endless too, but it is not true. We also need to plan carefully what to measure and how often even these days. The limits still exist. Let's suppose one measurement point. Unthinking user, who does not consider consequences, set the spectrum with 25,000 lines and time waveform with 32,000 samples. Each line and each sample needs 4 bytes on drive. It means more than 100 kilobytes for each spectrum and time signal. And now multiply because user wants to measure each second and needs to measure 16 machines with 5 points on each machine. He needs almost 2 terabytes for one day. Another problem is that such user wants to run these systems on a small laptop usually. I am worried that people would like to run such systems on smartphones in the future. How to decrease the data amount? The usual approach is to measure just in time intervals. For example, I measure the ISO RMS in millimeters per second. One measurement takes 1 second. I need to dilute the data. I set the time interval between measurements to 5 minutes. This setting has disadvantage. I do not know what was happening between measurements. The signal could be very variable. Look on the picture. The red dot represents the real vibration value. We started in first measured position. The value is 1.12 millimeters per second. Now we run the time. The red dot shows the real vibration values. But system doesn't save them. Next measurement will be saved after 5 minutes. It is clear that this way is not perfect. Adash wants to measure continuously. We developed a special online data management system which solved all mentioned troubles. Our solution meets both conflicting criteria. It means we measure all the time continuously. If the measurement takes 1 second, then 60 readings are taken in each minute. But we also decrease the amount of data. It means we save just reasonable amount of data. How do we do it? The main rule is this. If the measured value is the same, then there is no reason to save it again and again. But 2 measured values are never exactly the same. We define the special comparative parameter for that. It is the significant difference between values. It is defined in percent. We use 5% as default value. Let's suppose that the last saved value is 2 millimeters per second. We save next value if it is higher than 2.1 or lower than 1.9. The difference against 2 millimeters per second must be larger than 5%. It means larger than 0.1 millimeters per second. Take a look on example. We measure with one sensor on the grinder. We are measuring continuously. We are saving the data regularly every 5 minutes, regardless of the value change. And continuously we check the significant change level. In the bottom you can see the real-time values. It is the evidence that we measure continuously. Saved data are in upper graph. Now just one value is saved. 5 minutes are running. The second value is saved. Nothing significant happened in last 5 minutes. Another 5 minutes are running. The third value is saved. And again, nothing significant happened in last 5 minutes. And next 5 minutes are running. Now we will simulate vibration change by hitting the grinder with a hammer. It is the significant change, and you can see how the next data are saved. Now again nothing is happening and the next 5 minutes are taken. Then the next value is saved. From this example you understood how the procedure works. Now I show you the data collection with various percentage of significant difference. The vibration is real vibration data from the pump, which works with variable load. We started with 5%. This is a graph with both signals. The blue line are original all values and the red line are saved values. 8,661 values were measured and 309 were saved. Do you see that something is missing in the red graph, which contains just 3.5% of original amount of data? I do not. Now let's go with 10% of significant difference. This is again graph with both signals. Again, 8,000 values were measured and just 194 were saved. Do you see that something is missing in red graph, which contains just 2% of original amount of data? I do not. Now the last example with 20% of significant difference. This is again graph with both signals. Again 8,000 values were measured and just 116 were saved. It is just 1.5%. I think even 20% example contains all necessary data, which is sufficient for evaluation. The data dilution is the first function which decreases the data amount. As the second function, we developed our own Adash compression method. Our data size is just 25% of the original size. Look, for example, to this spectrum graph. The upper graph is uncompressed and the bottom spectrum is compressed. Do you see any difference? I do not. The important part of Adash online systems is DDS software. All settings are made in this software. The tree contains the structure of machines, measurement points, and types of measurement like overall, spectrum, time waveform, and next. The DDS also displays measured data. and from the DDS we run and stop the online system. On so-called real-time panels, you can display last measured values and you can see that system is alive. Advanced user can change above-mentioned default data-saving configuration setting. There is a short text file which contains parameters used for system control, but the default settings should satisfy all standard online measurement requirements. Many users are afraid of online systems. They suppose that it is much more complex than the using of portable units. It is not true. With Adash system, it is the same level. In Adash, the portable and online systems work with just one DDS software. You can simply share data from both systems. And the Adash adaptive system enables to have small databases and very quick data processing at once. Do you want any references? Our Adash systems are installed in all Czech nuclear power stations, even in primary circuit in a high temperature environment. Thanks you for watching.